There we go. Here we are live. Hey, Christian. Welcome to LambdaTest TestMu 2022. Um, thanks everyone for joining post lunch. I hope you had a good break. For different parts of the world, you're joining us, and can't be more exciting than having Christian Bromann here. Welcome, Christian, again. He's gonna talk about the evolution of browser automation, which is the most sought after topic, I would say, because it's also a topic that I've been researching about for quite some time, and I saw Christian giving talk about it in one of the OpenJS conferences, and I was intrigued about learning more about it. Also, in the previous talks that happened today, I don't know, Christian, if you notice, there were a lot of people asking questions around what is the reason behind a lot of frameworks that are based out of JavaScript but not other languages. Is it because front end is based on JavaScript? So all those questions were popping up. I'm sure all of those will be answered in this session because this is all about the evolution of browser automation itself. So, Christian, for you, and stage is yours.
Thank you, Manoj, and thank you all for joining the session. Particularly, thanks for LambdaTest and all the TestMu organizers for organizing this great event and conference. I'm very excited about all the talks that we see from various experts around the world in the next 2 days. And I was just at the panel discussion about the future of testing. It was really insightful for me, as I am not per se a practitioner, more like a test automation developer or test framework developer. So got a lot of insights from there, and really looking forward to hear about all the content that we have in the next 2 days, as our industry, is constantly changing and evolving over time. But in the next 30 to 35 minutes, I would rather like to speak about how the browser automation has evolved till today. Like we want to look a little bit back, almost 18 years now, what has happened, so that we got to the point where we are right now. And I hope it will give everyone a little bit more context about when they hear about certain test automation tools and in the upcoming session, and allows them to put them into certain buckets and understand where they come from as well. Before we start, let me introduce myself. I'm Christian. I'm working as a founding engineer at a company called Stateful. We build a lot of cool developer toolings and VS Code extensions. So if you haven't checked out Marquee on VS Code or the Issue Explorer on the VS Code Marketplace, go check them out. We have a product that allows you to, give you insights about your development habits and how you program. So if you're interested in that, check that out. But we are not here today to talk about the top 10 VS Code extensions, even though I could talk about that a lot. We're here because we all love automation. And most of the people might know me as a maintainer of 𝒃.io, which is a project that got me excited about automated testing and browser automation in the first place many, many years ago. Maintaining that project has taught me a lot of things from, generally how browsers work, taught me a lot of things about open source and open standards. And the reason why I wanted to give this talk is because I see a lot of misconceptions about how browser automation works. And I always kind of like have to laugh a little bit when I see these comparison blog posts like Cypress versus Playwright, because for me it's a lot of like comparing apples versus oranges, which doesn't really make a lot of sense. And I'm here today to provide some historical perspective and context as to why things are the way they are, and that might be interesting for you because I feel like as a user, there's not much delineation between the automation framework and the automation actually happening in the browser, because it's really hard to say when a click doesn't happen, even though your test script passes, or if your framework cannot find an element, even though you clearly see it's there. So with those automation problems, it's really hard to tell whether it's a problem in your test script, in your application, or in the framework, or in the environment. And I feel like as an automation specialist, you should kind of like have an idea at least where the error might be located in order to either fix your app, fix your test script, report the bug in the framework, or find a workaround because your environment doesn't provide what you want to do. So let's have a look and understand kind of like how a click happens using various frameworks. But before we do that, let's look into the past and understand what has happened over the last 18 years to kind of like also understand where we are right now. And it's really interesting to see as the web has changed over the last years. So have the automation frameworks changed. So let's recap a little bit to see what has happened. And we have to start all back in 2004. When a person called Jason Huggins came around, who had to test an expense tool over at ThoughtWorks. And back in the days, mostly everyone was using Internet Explorer, especially the business folks. However, there was a new browser around called Firefox. And so all the developers that wanted to use Firefox, and they saw themselves in a situation where the application was working in Firefox, but not in IE, and vice versa. So he built a tool which was called Selenium, which he used to kind of like make sure that the test works in both browsers at the same time. Now, kind of like a year later, another person jumped into the scene, Simon Stewart. He built a tool called WebDriver, also an automation framework, but that framework did the automation a little bit differently. Both tools, however, gained a lot of usage and popularity over the time. So Jason was like, might be a good idea to create a business. That might be a growing ecosystem. So in 2008, Sauce Labs was founded. And it was apparent at that time, that Selenium and WebDriver, which were both separate projects, they had their own limitations. Selenium was running in the browser and had problems with things like cross-origin policies and automation around the browser, something that we see actually in Cypress today too. While WebDriver had some limitations when it came around automating certain elements on the page. So Jason and Simon got together on a beer and were thinking about, hey, why not merge the projects together and create Selenium WebDriver, join forces and overcome these limitations to really provide the best possible experience at that time. And so Selenium WebDriver was born. And with the years, the way how we automated browser became more and more clear. The Selenium project developed the JSON wire protocol. And at some point, they experienced that, maintaining all these, drivers to automate browsers was kind of painful. And Simon thought, well, it might be a good idea, since we're automating web browsers, that we go to the WWDC and ask if we should develop a web standard around browser automation. So Simon did that in 2012, and the WWDC created a working group, including various of browser vendors at that time, to really build a standard with the goal in mind to have a click in Chrome being the same click as in Safari. And so that web standard started to be drafted, and all the browser vendors have been working on that. And that really created a lot of confidence and traction in the ecosystem overall, which started, a lot of tools back in the day started to flourish. We see, WebDriver.io being released, the first released in 2011, not by me, but by a Swedish guy. And we see, new frameworks like Appium bringing the same principle to the mobile space. But now we see kind of like an interesting change in the web ecosystem as a whole. The web kind of changes, and with that, also the way we build web application and the way we deliver web application. What used to be a web server that would deliver static pages are now dynamic single page application that fetches data from APIs using frameworks such like React, Vue, Angular, and Svelte. So that has changed a lot of the requirements of people that had to test the application. Suddenly front end and back end became more and more decoupled, and people, started more focused on the front end applications without really wanting to deploy the whole stack, including the back end. So people wanted to start, mocking out network responses. And with the web evolving, more and more web APIs became available that wanted to be tested as well in the context of the application. A lot of these new use cases were not really a focus point when all the browser vendors were developing the WebDriver protocol, and was also not a focus point for Selenium for that matter. So that's why there was a lack in certain testing capabilities. But luckily, we had companies like Cypress who have stepped in to fill those kind of needs in a really extraordinarily good way by developing tools with a great developer experience. And this lack of automation capabilities also generally created more focus in that space. So we see more tools like Cypress popping up in the ecosystem, like Puppeteer and Playwright, that really focused more on the idea of being able to introspect a web application rather than automated browser. But over all these years, we still were developing the WebDriver protocol, and we were developing it with the vision and mindset of how web pages have been built in 2012. And so in 2018 we finally got to the point where we were able to say, or not we, but the working group were able to say, the WebDriver standard as it is now a recommended standard. That means it was implemented by at least 2 browsers, and it was finally the start of moving away from the JSON wire protocol towards this new thing that was called WebDriver, that was really well defined and worked across browsers. But of course, the working group has seen the development in the web, and therefore we're aware that the way the WebDriver protocol was designed today doesn't really work for testing modern web apps these days. So at the same time, almost the same time as the WebDriver, the first version, became a recommended standard, the working group created the new initiatives to start developing a new version of that protocol, which we call WebDriver 𝒃𝒐𝒐. And they wanted to use all the experiences and learnings that they made creating the first protocol, but include all the requirements that we see that people wanted for building modern and testing modern web apps today. So that new initiative was created 2019, and now 3 years later, almost, we see the first primitives just landed in Firefox in version 101, which allows us to use, to listen to log events in the browser, which is really exciting. It's just the first primitives, but it's the start of a big change. So with that, we can pretty much today group the tools that are available into kind of 2 buckets. The one I would call then the more conventional tools like Selenium or Nightwatch, which uses Selenium, or WebDriver.io, which is a known implementation of the WebDriver protocol. And we have the so-called non-standard tools. And both groups have some interesting characteristics. Starting with the conventional tools, and as you probably have guessed, all of them use the WebDriver protocol as the automation engine. And with that, they really provide a true cross-browser automation capability, and even allow you to test on mobile and other devices. And the good thing about using a web standard is that every command in WebDriver is tested in every browser. So every time a browser is released, there's a test suite that is running to make sure that the click in Chrome is actually the same click as in Safari or in Firefox. The design, as I mentioned before, of the protocol is kind of like be able to do everything that the user would be able to do, which now looking at building modern web apps today is not really suited for developers, because they really want to introspect everything that's going on. So that's why tools like WebDriver, Selenium are mostly used by quality engineers and QA folks that have to test on a broader surface across multiple browsers and devices, and building large test suite. While for developers, who just want to write small integration or end-to-end tests for the front-end apps, those frameworks might not be the first choice. However, the great thing, personally, that I feel like about these group of tools is that they all open governed and open source with a long history and large community. So WebDriver.io, for instance, is part of the OpenJS Foundation alongside Node.js, Mocha, or Webpack. And Selenium is a project of the Software Freedom Conservancy. So that means that everyone who's interested in contributing to these tools can do so, and in fact will be able to have more voice and more impact controlling or steering this project in the way that they would like to. On the other side now, we have the so-called, I call them non-standard tools, which they all have their own way to automate the browser, and they all have their own set of advantages and disadvantages over each other. So these custom approaches are either done through JS emulation or using browser APIs, and that makes them kind of limited to certain browsers, but allows to access capabilities that WebDriver-based tools probably don't support out of the box. And that makes them interesting for developers because they provide these introspection capabilities. on that side, we have an interesting fact that all the tools that are developed here are kind of like baked and governed by companies with sometimes multiple people working on those projects full time. So if we look at those tools, we have Cypress and TestCafe taking the approach of mostly using web APIs and JavaScript emulation. We have Puppeteer and Playwright that rely on native browser APIs. And lastly, Selenium and 𝒄𝒏𝒂𝒏 and many other WebDriver-based tools that use the protocol. What's worth pointing out here is that some tools like Cypress and 𝒄𝒏𝒂𝒏 actually use a mixture and hybrid approach as well. So for some automation capabilities, Cypress needs to use browser APIs, for instance, to take a screenshot of the browser or providing some of the beloved debugging capabilities. On the other side, we have 𝒄𝒏𝒂𝒏 that uses the browser APIs for its performance testing features or its integration into Google Lighthouse. And while all these tools basically do more or less the same, and they all help us fulfill a certain task, they are quite different if you look into them in detail. So be cautious, really, if you read these comparison blog posts, because many of them try to mostly, highlight the good of the one and the bad of the other. While it isn't generally okay to show differences of certain tools, the lack of feature X is often not an intentional decision of the framework author and often just a technical limitation that was chosen to have an advantage over something else, right? So the golden rule, which I could recommend, is if you have to pick a framework, really take some of them and take them for a test run. And ideally, you pick a framework that, is part of either of those buckets. Either uses web APIs, browser APIs, or the WebDriver protocol. And let's walk over them, because it's good to understand what every of those approaches has the advantages and disadvantages for. Starting with using the web APIs as an automation engine. And I picked that first because I think using web APIs is kind of like the first generation of doing browser automation. Even though we have some more novel tools like Cypress or TestCafe that are using this approach, it has been actually around since the creation of Selenium in 2004, which was, like Cypress, more or less a test runner within the browser. In fact, some automation commands like finding if an element is visible, here Selenium still uses JavaScript and injects JavaScript into the page. This is mostly because the idea or the definition of an element that is visible is kind of like hard to define in the context of a web standard. So that's why most of the frameworks have their own definition of what it means to be visible as an element and have their own implementation of finding out if an element is visible or not. The advantages of using web APIs is obviously that you have the full control of the execution environment of the application under test, because you run within that execution context, and it allows to run those commands fast and reliable. However, you can kind of like only do what the JavaScript and the web APIs allow you to do, which is a lot, but definitely not everything. And so you need to have some workarounds to get outside of that JavaScript sandbox. When using JavaScript as an automation engine, you need to kind of like find a way to execute a certain test runner script within the application you want to test. And here there are kind of like two approaches mainly. One, which is used by Cypress, where you run an application under test in an iframe and have the test runner in the parent frame, accessing the same execution context. So the browser loads a test runner, and that renders an application under test in an iframe. And so the test runner can access that iframe and can access the JavaScript sandbox within that iframe. And TestCafe has a different approach, as it uses proxies to kind of like inject the test runner environment into the web application. So that proxy approach has the advantages that it allows to automate more than just URL and your origin, but it also gives you less introspection control between the test runner and the application under test. Generally said, the limitation here is that you are caught in the JavaScript sandbox and only have access outside of it through workarounds, for instance, using browser APIs. The second generation we should talk about are browser APIs. I would call it the second generation because it was also the approach of the original WebDriver project to automate the browser. Back then, kind of like a common way was to abuse browser extension to trigger commands on the website. Or, for instance, the Internet Explorer was automated through the COM interface that Microsoft provided for some of the automation capabilities. And today we see that browsers have evolved, and all of them now provide an exhaustive protocol that allows you to introspect whatever happens inside of that browser. And mostly we've been using that protocol for debugging, using the Chrome DevTools application to debug what's going on in our app. But that Chrome DevTools application and behind the Chrome DevTools protocol is these days also heavily used for automate browsers, for instance, in Puppeteer or Playwright. The problem with these browser APIs is that they all work differently. Every browser has a different browser API that works differently, and they are unfortunately not really documented in the sense outside of browser teams, and they also change a lot. From one version to another, there's no backwards compatibility. So every time you have a new Chrome release, you will have to update Puppeteer in order to test the latest Chrome. Think about it as given you have 3 browser friends that want to help you to automate or to test a web application. So in order to give all your 3 browser friends a command, you have to be able to speak all their languages. And so to give them a command, you have to understand and you have to speak with them. And that's difficult because, for instance, Safari doesn't even want to listen to you because their browser APIs are hidden behind the Safari wall, let's say. It makes it difficult to automate 3 browsers at a time because they all speak different languages. So these days you have Puppeteers that was mainly used to only automate Chrome-based browsers, but luckily we have now browser vendors partially joining forces to speak a more similar language, which is why Puppeteer can now also partially automate Firefox. And we have former browser teams that have implemented some sort of custom adjustments to browser engine. Basically, I would call them handheld translators to do the same type of communication which we see in Playwright. Lastly, let's look into the WebDriver protocol, which I would argue to be the 3rd generation, as it really combines the 2 previous approaches to ensure a consistent automation experience in all browsers. It's a web standard. This means it is actively developed by browser vendors as well as regularly tested. So all changes or all definitions in the protocol have a test that is being accompanied with it. And so, again, the original designs was not really, it failed to meet the requirements for testing modern web apps today, which is why, you have the WebDriver BiDi effort going on. And the way the WebDriver protocol works there is that you have a driver that is provided for every browser that allows you to translate a well-defined command, like a click on an element, into automation commands that the browser understands. And in many blog posts, you see WebDriver and Selenium being referred as slow and outdated. And one of the reasons for that is that translating the WebDriver commands, is an extra step that needs to be done by the driver. And that extra step, takes some time. Think about using WebDriver as if you would manage as a test author a browser factory. But of course, due to COVID, you have to work from home, and your home in this case has no internet or telephone. So in order to, tell your factory workers what they need to do, you have to send an assistant over to that factory so that the assistant can tell the workers what they need to do. That, of course, might take a while, but once executed, your assistant comes back and tells you whether or not your command was executed successfully. But this can take up to sometimes 200 milliseconds if you test, in the cloud. And on busy days, you might want to run 1,000 commands in a single test, which is obviously not a really, effective way to run a factory. However, a single a single command and transaction is slow, this approach has the advantage to be very scalable. So, you can have 10 assistants to automate 10 factories at the same time. And another benefit is that, with this approach, you can not only automate a browser factory, you can also automate any kind of factories, a mobile factory or an IoT factory for that matter. So let's say you run a browser factory, you need to have an assistant that understands the inner workings of a browser, being Chrome or Safari. If you have a mobile factory, you have an assistant that understands iOS or Android. So the idea of having this translator for executing a trivial command like a click on a button in a complex user agent like a browser kind of works pretty well. Now, as I mentioned before, your assistant here is not really able to do a lot, and you have no idea what's going on while your assistant is gone because you don't know you don't have a telephone to call to the factory. So these are really well-known limitation of the WebDriver protocol, and with the new effort of the WebDriver BiDi, these kind of like limitation will be removed. And given our little thought experiment here, when we now switch to the new protocol, the whole world would kind of like now look like this, where you as a commander would kind of like oversee not only the factory directly, but also a lot of other domains in your ecosystem that you're interested in. So instead of telling one command to your assistant at a time, you can give multiple commands at the same time to multiple actors while you listen to various of inputs to things that you're interested in. That makes you, I would almost say, that makes you some sort of automation god. And so that's why this protocol is called WebDriver BiDi, which stands for bidirectional. And it comes with some interesting features here. For one, again, it tries to address some of the capabilities needed today to introspect things like the network, the DOM, or the console. So the protocol will likely ship with primitives to modify data on the network level to help you introspect the DOM events to ensure that you can flawlessly handle various of elements at the time. In addition to that, it really provides with enough access for us framework implementers to be really creative when it comes to building these frameworks. For instance, it will have some sort of bootstrap script that will be executed before your app is being loaded, and so we are allowed to monkey patch certain APIs and web APIs in order to have more control about what's going on in the application. And like the normal WebDriver protocol, this new version will be also backwards compatible, so you can test multiple versions in the past, and it will also come with the machine-readable API specification. So creating tooling around the new protocol would be much more easier. That said, the protocol is in the making, and like all standards, feedback is really important here. So if you automate a browser, which I think a lot of us are doing, come to the working group, join the GitHub channel, and provide some feedback about things that you wish you want to be able to automate but don't find anywhere in the ecosystem. That feedback is really important for the spec writers to understand what they need to focus on. What's also interesting is that this new protocol kind of like changes a lot the way how we run tests in the future, because this model requires a test framework to exchange a lot of more data as opposed to the old protocol. If you remember the picture, instead of having only one communication channel, this time you will have multiple channels, multiple sources of information that you can do to set multiple commands at a time. So again, while the current version, you send one command and wait for the response, the future, you will be able to send 1,000 commands and get 1,000 responses at the same time, which has its own challenge, particularly for cloud vendors like LambdaTest. Their current business is kind of working fine because you send one command over the internet and wait until this command arrives at the data center, and then you get a response back and you can send your next command. With the new protocol, this kind of becomes difficult because by sending thousands of commands and receiving events from all sides of your application, there's technically a possibility that you can DDoS yourself, or that you can DDoS your own CI server. And so while the spec writers are really aware of this and are building on commands and features that will reduce the chattiness of the protocol, there will be some problems where cloud vendors like LambdaTest need to find answers to. And we see across all vendors a bunch of interesting developments in that space. For one, we see the execution model, for instance, changes. You don't send a single command through the internet anymore because your test lives on the different side of the world. The browser and the test start to move together so that it is possible to exchange the amount of data between the browser and your test framework. So you will see more trends towards, your browser vendors will asking you to upload the test to the cloud or run the test in their kind of like controlled environment. Or we will, more test in, browsers that we have installed in our CI machines. Another trend that I've seen is that functional testing alone is also not the only way how we're going to measure quality in our applications. Vendors will be more apparent throughout the software development lifecycle. And so cloud vendors like LambdaTest will accompany you through the development, testing, and release process all the time. And so they will capture information from all sides of the spectrum and they used to indicate, that help you to indicate what's going on in your application at all times. We also see a lot of vendors offering multiple kind of like approaches to testing, right? We see vendors offering API, security, accessibility, and component testing, to provide much more abilities and methods to control and capture quality signals. And most importantly, they use them across the board to create really smart conclusion about what's going on and help you to steer your application from development to production. So all of these are really interesting developments in the cloud vendor space that will be even easier and even more interesting once we have the new WebDriver BiDi protocol. So what's next? How will the future of browser automation will look like? Well, honestly, I don't know. I can't really tell that for sure. I also don't want to recommend and say, use this framework over everyone else. I'm really excited about the fact that we have so much development going on in the space. And even though, I would like to see the WebDriver protocol succeed, but at the same time, I'm rooting for tools like Cypress and Playwright as they push the boundaries of automation and really provide fantastic experience using their tools. And honestly, without these frameworks and these new frameworks, I wouldn't see the kind of development in the standard space either. That said, I think if we want to improve the quality of the web altogether, it really doesn't go without looking at web standards too, which is why I'm excited about the development that happened in that space. So for one, again, the WebDriver BiDi protocols, which will enable tons of opportunities. With all these three approaches that we talked about combined, it really creates a lot of great chances for us as framework implementers to build the tools that can effectively test and automate the web application you build in the future. And it's also very exciting to see a lot of web standards being shipped with WebDriver extensions. We have, for instance, the web authentication standard that now allows you to create virtual authenticators in WebDriver. With very recently, changes in the HTML spec, caused these spec writers to implement commands to change time zones in the browser. And there will be more APIs in the sensor space, browser reporting, and permissions. And they all new web standards will come hopefully soon with a WebDriver extension so that we have more and more control using a way, to control all browsers in the same way. That said, creating any form of standards usually, is a very slow process. And you have to get people on board. You have to make sure that what you standardize makes sense for everyone. And you have to write the spec and you have to implement it in browser and you have to test that. So, these changes will surely not happen over time, but it's really good to see all these developments in the tooling and standard space. With that, we are almost at the end of my talk, and I want to finish with the following quote from Maya and James, who have been both working on the Firefox browser and have been a tremendous impact, working on the WebDriver specification. And they said an automation solution based on a proprietary protocol will always be limited to the range of browsers it can support. The success of the web is built on multi-vendor standards. So it's important that test tooling builds on standards as well, so that tests work across all browsers and devices where the web works. With that, thank you so much for the opportunity to speak. I think we have 4 more minutes for question and answers. So I'm really excited about that. Thank you everyone for participating.
Wow, what a session, Christian. Thank you so much. Did you had a chance to breathe yourself? Great. That was a fantastic talk, Christian. I think by far the best that I've heard about when someone talking about the evolution of browser automation. I really loved the
Thank you.
slides that talked about how you segregate different browser vendors, specifically around the first generation, second, and third generation. There's a couple of questions already on the Q&A panel, but before that, I think this will also be a question that will pop up in a lot of people's mind when they look back the recording when we posted on YouTube as well. So on the WebDriver IO, you mentioned it supports already the browser APIs as well as the WebDriver protocol. So does it mean that the WebDriver IO is already way ahead? Having the most of the WebDriver by day that is people are expecting to come out is already implemented in WebDriver IO. Is that the case?
So yeah, WebDriver IO uses, again, as I mentioned, the browser APIs for performance tests in using Google Lighthouse, and has some other features, but I don't know if it's like ahead of anyone else. It's just some neat features and functions that the tool provides. It allows you also to run all the WebDriver commands using Puppeteer, because sometimes it's just easier not to have to install a driver. So they all have their reasons. With version 8 of WebDriver IO, we will have built-in support for the by-day capabilities, which will be exciting. And so that version will come up in the next months, and so people can start using all these new interesting features that will be embedded in the upcoming browser version, and they're already part in the new specification.
Got it. Thank you. And slightly another question related to the comment around, and thank you specifically for coding Lambda test at multiple instances, and how to be getting prepared for the evolution of WebDriver ByteEye when it comes, especially. So my question is related to that. So a lot of enterprises have their in-house grid setup. You must have seen a lot of implementations. So what should those companies or those architects, test architects, should be doing, imagining they have Docker instances or Kubernetes instances, or spinning off on-demand instances based on tests? When the WebDriver by day comes, we all know it's a chatty protocol. So what are some of the proactive measures that the testers could take it?
So I think if all of them uses the Selenium grid in order to manage the whole pool of browsers and devices, I think they are well set up, because the Selenium grid will be able to support the new ByteEye protocol, and you'll be able to use the features. I think when it comes to the operational part, in terms of DDoSing your own CI system, I'm less concerned about that, because the spec writers are aware of that problem, and they will make sure that the ByteEye protocol will be not as chatty as the current DevTools protocol is. So I don't think it will be a problem. For cloud vendors, it might become one, because sending a lot of socket messages across the globe can cause race conditions, as we know, and like some other problems that we might not even be aware of. So running an in-house grid is fine, and you will be well set up. However, maintaining that grid, that's always the argument of a cloud vendor. Maintaining that grid will cost a lot of time. If you can afford that, that's great. Then you can specify it to the needs that you have. If not, like, I think cloud vendors will build out great tools moving on, and will serve us well as well.
That was sharp and to the point. Thank you, Christine. Let me pick up some questions from the Q&A panel. So here we go. A question from Manish. How much multi-language support is important when picking up a browser automation tool?
Well, obviously, I believe that the tool needs to be suited for the team that uses it. If you have a tool of QA engineers that have knowledge in different languages, or have only knowledge in PHP or Java, then they should use a framework that is built in Java or PHP. um, we have seen the question in the past, like in the other sessions, like we see more and more JavaScript frameworks being popping up, and that's why I believe, the time where we deploy the whole stack, where we write a backend in Java and kind of like have a little front end part. The front end part now is more and more bigger, and we do end-to-end testing without deploying the whole stack, so we don't even need the backend that much anymore, which left us with JavaScript, and then you have a team that have to maintain these tests that also builds the application, which is probably people that understand JavaScript. So I guess we will always continue to have test frameworks in all kinds of languages. I think that is important. But when it ends up picking a framework, uh, take a look at what your team feels comfortable using, and pick that.
Thank you. Our next question from Gustavo. Is there or will be anytime soon the possibility of having extensions like the Chrome extensions in these tools available to be part of browser context when running automated tests?
So does this mean like installing Chrome extensions when running tests on Chrome? Do I understand that right? Browser context when
I perceive it the same way as you do.
I think right now you can already, at least in Chrome, have a Chrome extension installed while running tests on it. I'm not sure about the other browsers, but this is one of the feedbacks that I was talking about. If there's indeed a need in our industry that we are not aware of, that a lot of people need to test extensions in Chrome, Safari, and cross browser, then that certainly we need to consider that when we spec out the protocol. But so far, I haven't been aware that a lot of people are testing Chrome extension or extension in general.
Got it. Got it. This question is slightly, I think you covered it at a broader range. So I think the question is from Yogendra. What one should prefer over the other W3C JSON wide protocol or tools developed to utilize dev tools of browser? This is a question. Probably we need a more elaborate question, but I think let me summarize it for you, or probably this will help answer a lot of users. So, Christian, is there a distinction as a user to make on when should we use a particular protocol, like say BiDi in the future, or right now use JSON wide protocol or W3C?
I think that's what I mentioned in the beginning, when you see the three buckets of kind of like tools that you have using JavaScript emulation, example Cypress, using browser APIs, Puppeteer or Playwright, or using the WebDriver protocol, WebDriver and Selenium. It really comes down to what your automation needs are, and based on that, you pick the automation engine that works best for you. So that said, if you still run on the JSON wire protocol, I beg you to update, because you soon might not be able to run tests on the browser anymore, because that protocol has been deprecated for a long time. Whether you have to choose WebDriver and a WebDriver-based tool, a browser API-based tool, or a JavaScript emulation tool, really depends on what you like, what kind of features you like. Again, a front-end developer might pick Cypress because the front-end developer is only interested in testing on the latest Chrome. However, someone else wants to test on all the browsers, including Safari, and actually prefers a real browser as opposed to like not a fake browser, but a modified browser that you get with Playwright. So it comes all down to your preferences, and the tools that you at the end fits your needs when it comes to testing your application.
Wonderful. Thanks, Christian. With that, we are sharp on time, 45 minutes. Thank you so much, Christian, for your time.
Thank you all.
And thank you all. Thanks everyone for joining the session. I hope it was quite insightful session. And as usual, a friendly message that all the sessions have been recorded and it'll be posted on YouTube. So Christian will be hanging around for a couple of minutes over the speaker launch. So if you have any more questions, please hang around with Christine on the speakers launch. See you on the next session. Thank you very much. Thanks, Christine.
See y'all. Bye
See ya.
bye.
Bye.